All right, what this means is we're going to add up every number of the form 4k minus 9 for all the values of k, whole numbers only, from k equals 5 to 100. Meaning we plug in the lowest number, uh, the lower limit here. If k equals 5, then this is 4 times 5 minus 9. And you can use your calculator if you want to. 4 times 5 is 20, and 20 minus 9, I think, is 11. And then the next number you plug in is not 2, like I did last week. The second number you plug in is one more than 5, and that would be 6. So when you plug in 6, you have 4 times 6 is 24. 24 minus 9 is 15. And the next number you plug in is 7. And 4 times 7 is 28. 28 minus 9 is 19. And
Hey, Professor, real quick, why are we increasing it by one again?
because that's what this means. You start
That's what the
you start with 5. This is what does it mean? Were you here that day last week, Wednesday or Thursday?
it's the end thing, right? And then so this is what you have to add one to.
Okay, you start with 5, and then you
Yeah,
go to 6, 7, 8, 9, 10, all the way up to 100.
yeah, yeah. 100 is the last one. Five is the
That's
first
right.
one.
And that's what these limits tell you. The lower limit tells you the first number to plug in. The upper limit tells you the last number to plug in. And they're all whole numbers, and it goes up by one. That is just what this means. And I know if you've never seen this before, this can be really weird. So
Okay.
the reason this goes up by 4 is this: every number that you calculate is 4 times something minus 9. Well, obviously 4 times 5 minus 9, and then 4 times 6 minus 9. For k equals 5, you have 5 fours. For k equals 6, you have 6 fours. In both cases, you're subtracting 9. That's why each number is 4 more than the previous, and that's why every series that looks like 4k minus 9 or 4k plus 12, it's always going to be an arithmetic series. And in order to figure out what the answer is, we have to go all the way to the last number. And the last number we plug in is 100. Now, there's two, as I mentioned last time. Let me put my phone on stun here. Phaser's on stun. Uh, the last number you plug in is 100, but that doesn't mean that the last number of the series is 100. Just like the first number you plug in is 5, but the first number of the series is 11. So now we're going to plug in 100. When we plug in 100, we get 4 times 100 minus 9, which is 400 minus 9. I think that's 391, but that's just a wild guess. Okay, not that wild. All right, then we go to the formula, and here it is. Okay, so what we need for this formula is three things. It's usually called capital A sub n, at least in this country. We need to know what A sub 1 is. Well, what's A sub 1? That is this, A sub 1. That's 11. Oh, okay. And what does A sub n mean? In this class, I'm using this. It's not A sub 100 because there's not 100 numbers. There's only less than that. So this is A sub n. That's equal to that. So all I need to know now is how many numbers there are. Well, there's two ways of doing that. One way is to use this formula on page 40 that says a sub n minus a sub 1 divided by d plus 1, where a sub n is the last number, uh, a sub 1 is the first number, and D is the adder. And that's how many numbers there are. So for this series, let me get that a little bigger here.
So, hey, professor, real quick, the
Yeah.
all of the numbers being four apart, and then four also being in the equation, is that a coincidence, or like, like 11, 15, 19, like they're all four apart, but then 4K, like the four is in there, like, is that like a shortcut, or is that just a coincidence? Yeah, you know what I'm trying to say?
No, not
Is this a
really.
coincidence?
You plug in 5, and this 4K means 4 times K. When
Yeah,
K
yeah,
is
yeah.
5, that's 20. 4 times 5 is 20. 20 minus 9 is 11.
Yeah. You know what? Forget my question. I answered it myself. Thank you.
Okay, great. All right, so here, the number of numbers, ah, the number of numbers is the last number minus the first number, and the last number is 391. So it's 391 minus 11 divided by D, and D is the adder. And what we're adding now is 4. But that's not the end of it. Then we have to say plus 1. And so that's equal to, well, 391 minus 11. You can use your calculator if you want to, but that's 380, I believe. I hope I haven't made an error because sometimes I do. Divided by 4 plus 1. Now, 380 divided by 4 is 95. 95 plus 1. Yep, that looks good. And 95 plus 1 is 96. Now, nothing wrong with that, but maybe you remember last week when we had sigma notation, the sum from 100, from 5 to 100. Uh, hey, we have an easier way to do it. Really, I kid you not. We have an easier way to do it. This is on page 41. The upper and lower limit can be okay. The number of numbers is the upper limit minus the lower limit plus 1. So that's the other way of doing this. And looky here. The other way to do this is say, look, n equals the upper limit is 100 and the lower limit is 5. And then you add 1. And 100 minus 5 is 95 plus 1 is 96. I think that was a lot easier, don't you? No need to answer. Of course it is. All right. So, so what? Well, that's not the way you're going to do it. You can do it that way, and some people did last week, and they were thrilled to get, quote, the right answer. So if you look at the sample problems on page 42, some of you were saying, I don't know how to key in, I don't know what to do with Wolfram Alpha to get it to work the problem. Well, here is an example right here on page 42. There's a bunch of examples. Wherever there's a sigma, it says sum from k equals 7. It says that for number 2. But for our problem here, instead of going through all of that trouble, can we figure out what to how to describe this series so that Wolfram Alpha will understand it and do it for us? Well, this one over here is from 7 to 984. Well, what's the lower limit here?
5,
That's
right?
5. And what's the upper limit?
The 100.
And it's not 4K, it's not 13K. I mean, it's 4K and not minus 7 minus 9. All right. For those of you who answered and said, I forgot how to plug it in. Great. Then use page 42 as a guide. You're supposed to use your notes. And I maintain that this topic is weird, but it isn't really hard when you follow that didn't work out well. When you follow the directions and look at the examples. You got a bunch of them. That is the code. This is how you read it. You read this is read the sum from k equals 5 to 100 of 4k minus 9. That's how you read it. And that's what you type into Wolfram Alpha. Oh, really? Yeah, I kid you not. Let's see. All right, Wolfie, where you are? Here you are. And here, now I'm going to copy and paste it just because I can do it faster. And then I'm going to either click equals or hit the enter key. It doesn't matter. And in about 3 hours, it'll work this problem out. Oh, wait, that was more like 3 seconds. So 12,296. I'm looking at my chat box, and that is 19,296. I think everyone got the same thing. And considering how quickly they did it, I'm going to guess that they effectively used Wolfram Alpha. So there is the answer, and this is the code. You keyboard it in, or if you have it on a computer where you can copy and paste it, you copy and paste it in. And here's very important. After you key in the code, this is called the input interpretation. This is what it interpreted that to mean. And if that indeed is what this means, and I mean, look at it, it is identical. So that gives you confidence that this is the right answer, 19,000. I submit to you that again, okay, this is weird. It's not hard. And some of you had the experience of having a private tutoring session with me, talking about the variation where you had 7 painters painting 12 houses in 18 weeks and that sort of thing. And some of you were totally confused. And then I had a little session with you, and you're like, "Oh, this isn't hard." No, it's not hard. The fact that it's something you've never done before doesn't mean it's hard. It means you got to get some experience with it. All right. Any questions? Maybe the
No, sir.
fact is, I'm sorry.
I said no.
Maybe the fact that this, see, part of the trouble here is this is not a long problem to work with Wolfram Alpha. It's really short. You type that in, hit the enter key, and that's all you do. I mean, I think it's a lot easier than doing what I did here. Uh-oh, now I've done it. I've lost my group here. Uh-oh, not good. Okay, that's better. Sorry, I'm trying to get all this stuff so I can see it at the same time. All right. So let's go to the lesson for today. Well, an arithmetic series takes account of taking a number like 9 and then adding something, add 6, add 6, add 6, add 6 until you get to there. Or you could take a number and subtract 5, subtract 5, subtract 5 until you get to there. So adding and subtracting are covered by arithmetic series. Great. You're welcome. Okay. Now, okay. The other two common arithmetic operations besides adding and subtracting are, guess what? Multiplying and dividing. Really? Yep. So for example, a series is not arithmetic but geometric provided it has a multiplier so that each term is obtained from the previous term by multiplying by the same number every time. What the heck does that mean? Let's look at the example. 5 plus 20 plus 80 plus 320, yada, 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 all the way up to there. Oh my goodness. Now you'll notice that this is not arithmetic because why? Well, 5 plus 20. Well, 20 is 15 more than 5, but the next number is not 15 more than 20. So it's not arithmetic. So you got to have something else, some other way to do it. All right. So we call that geometric because after the 5, every number is 4 times the previous number. And here is how you do it by hand. Uh-oh. If a sub n is the sum of the first n terms, here is the answer. Cool. Well, let's see. How does that work here? Let me go down to a fresh page. The total of all these numbers is calculated with this formula. A sub n times r minus a sub 1 divided by r minus 1. Now, again, what the heck is a sub n? That's going to be the last term. So for this problem, I'll call it geometric series. For this problem, the last number is 81,920. Okay. Now I have to multiply that by r, and the multiplier is 4. So multiply that by 4. And then I have to subtract the first number. I could go through why this works, but no one really cares. And the first number is 5. And that is going to be over r minus 1. Now r is, the multiplier is 4. And you don't have to put 4 minus 1. You can just put 3 if you want to. All right, so let's get our handy dandy calculators out. And unless you have a scientific calculator like this one, you can, if you don't have that, you can work this one with a regular calculator. It doesn't look quite so daunting. All right, so 81,920. And you look at it, whoops, and hit the wrong button. 81,920 times 4 equals that. Now I'm going to say minus 5 equals. I'm not going to say minus 5 divided by because I wanted to make sure that it subtracts 5 first. So minus 5 equals, and then that number is divided by what? Don't say divided by 4 minus 1 because it'll divide it by 4 and then subtract 1. Go ahead and say divided by, I'm confident you can do 4 minus 1 in your head. And that's 3. And so the answer is 109,000. We hope the answer is 109,225. Let's find out if I did that right. Now, the cool part of this is, uh-oh, I don't have sigma. Oh no, I don't have sigma. Gosh. Let's see if Wolfram Alpha can figure it out without having sigma notation. It could on some of the arithmetic, but I don't know if it's going to work here. I really don't know if it's going to work here. Oh my goodness. Look at it, 109,225. Yay. Furthermore, Wolfram Alpha figured out how to tell us this. Really. Yes, it did. It said, you know what? This series is the same as the sum from n equals 1 to 8. So I'm going to go to here, the sum from. Now they used n. I'm going to use k because I like k. That's my sister-in-law's name. She's in uppercase. This is a lowercase. That doesn't make any difference. Upper, lower, doesn't matter. From k equals 1 to 8 of 4 to the n minus 1. Now, someone told me one time when I had this formula like that. Someone told me, well, 4 to the n minus 1, you do 4 to the n before you subtract 1. That's really tricky because the exponent is n minus 1. This does not mean 4 to the n and then subtract 1. All right, now the trick is going to be, how do you do that? Well, with a scientific calculator, you're going to find it's going to be a lot easier, or at least possible. So 4 to the n minus 1, good grief. Now, here's something that most people have forgotten. When you plug in 1, you do n minus 1, and n minus 1 is 0. Now, I will tell you that most people think that 4 to the 0 power is 0. It is not. 4 to the 0 power, 4 raised to the power of 0, is actually 1. Really? Yep, it just is. Ah. But notice I forgot to put 5 times. So let me go ahead and modify this. Let's see if I can make this happen. And then here, I need to put 5 times. Now I can put 5 times in lots of different ways. I could put the 5 in parentheses, or I could put 4 to the n minus 1 in parentheses, or I could put I can put x for multiply, because there's no x's in here. I can put x for multiply. No ambiguity there. It doesn't look like x. See, they look a little different. Or sometimes you might see in algebra for multiply, we use a raised dot. That's not 5 point, that's 5 times. So when you do 4 to the 0 and then you multiply it by 5, guess what you get? You get 5. That's the first term. Oh, cool. I like that. And there are other ways of representing this same series. So if you're lucky, you'll have one, the ones you have on the test will look like that. Oh, look. The sum from 0 to 7 of 5 times 4 to the k. That's how I would write it. 4 to the 0 is 1. To expand this, write it all out, we replace k with 0 through 7 and add the results like this. Oh my goodness. Now how do I do a power? How do I do, for example, 5 times 4 to the 7th power? Well, it's 5 times 4 raised to the power 7. And I will tell you that your scientific calculator will do 4 to the 7th power first and multiply that by 5 and wind up with 81,920. Isn't that cute? Now, a lot of people don't really, uh, they're surprised when there's only 8 numbers here. Really? Yeah, well, guess what? I'm going to modify this briefly. So if I filled this in, I got 1, 2, 3, 4, 5. The next number would be 320 times 4. 320 times 4. And that's 1,280. And then this number times 4 is 5,120. And then that number times 4 is 20,480. And then multiply that by 4. Then, oh my goodness, look how we're there. There's no dot, dot, dot anymore. Wow. So there's only 1, 2, 3, 4, 5, 6, 7. There's only 8 numbers. And this is what people mean when they say things like, this is growing exponentially. And like the coronavirus, for example, growing exponentially. And what that means is it could get pretty big really fast. That's what that means. All right. So what? So find each sum, find the sum of each of the following series. This says check your answers, but just like last time, you don't, I'm not requiring you to do this by hand on the test. You should be thrilled that you get to use Wolfram Alpha. And I have given you the code right here. Really. So this is no longer 7k plus 5. This is going to be the sum from j equals 1 to 8. This is 2 times 3 to the j. And when you plug that in, Wolfram Alpha, you'll see, just to show you, that, well, that's not fun. Boy. You will see, I hope. You plug that in just like I wrote it. And there's more than one way to put, wow, that was fast. That's pretty cool. I'm thinking that's cool. Correct me if I'm wrong. All right. Now, it gets a little tricky when there's fractions involved because fractions are kind of weird. However, you can use those 3 samples of what you put in there, and you don't have to use I, J, and K. You can use any letter you want, really. But I'm going to ask you to try to figure out what the rest of the code would be. And oh my goodness, the answers are on page 46. So for your work, I used to say group work, but we don't really do group work anymore because we don't have the privilege of being in the same room as each other. So to help get you ready for the next test, please use this time, unless you have a pressing emergency, to work the problems on page 46. You can work them by hand if you want to, or you can work them by going to Wolfram Alpha. You're not working them, you're getting the answer from Wolfram Alpha. Just be sure that when you plug in the code, the input, the Wolfram Alpha interprets this to mean what this says. Any questions?